Hello friends, welcome to engineering tutorial. So this is the third question related to diode connections, and this is the circuit that we have. Again, it has a silicon diode. It is connected to the P end is connected to 0.4 volt, and it has a 500 ohm resistance, and it has been asked to find the value of this current I and the voltage drop across the 500 ohm resistor. So again, like we did in all the previous questions related to diode connections, the first most important thing to determine is the state of the diode. Okay, whether it is forward biased or reverse biased, or on or off. So there are two ways to do this. Again, for your better understanding, I will be using both the methods. So first method is by assuming that the diode is off or open circuit. Okay, 4 volt plus minus Vd and 500 ohm resistance. As the diode is open circuited, no current will flow through the circuit. When we apply KVL here, we'll get 0.4 minus Vd minus 500 into 0 equal to 0, or in other words, Vd is equal to 0.4 volt. Vd, the voltage across the diode, is 0.4 volt. Now we know that for a silicon PN junction diode, the forward potential, the barrier potential is 0.7 volt. For germanium it is 0.3 volt. Here it is silicon, it has been mentioned. So the forward barrier potential is 0.7 volt. So in order for the diode to be in forward bias condition or to be in on state, this voltage across the diode must be greater than 0.7 volt. But here we are getting that the voltage across the diode is 0.4 volt. 0.4 volt is lesser than 0.7 volt. So this diode here is off, reverse biased. It will be open circuit. As it is open circuit, current will be, this current will be 0 ampere. As this current is 0 ampere, no current flowing through the 500 ohm resistor, V 500 ohm, the voltage drop is also 0 volt. Okay, this is the first method of analyzing the circuit. Then we'll see the second method also. Okay, so we'll see the second method. Okay, let us erase all of this. Okay, in the second method we will assume that this diode is on. We'll replace it with its built-in potential, the equivalent circuit. So the equivalent circuit 0.7 volt. There has been no mention about any forward resistance, so no resistance, diode resistance will be included. This is 500 ohm, this is ground, this is 0.4 volt. Okay, now we have to find this current. Okay, So here, to find this current, we'll apply KVL. The KVL will be 0.4 minus 0.7 minus 500I is equal to 0. That implies I is equal to 0.4 minus 0.7 by 500. Now, there is no need to proceed any further. This numerator, it will be negative. 0.4 is lesser than 0.7. So this value of current, it will be negative. When it is negative, it means that our assumed direction here, the actual current is flowing in the opposite direction. This is the actual direction because the value of the current is coming with negative sign. This is the assumed direction which is asked in the question. The actual current is in the opposite direction. So it means that the current is flowing from N to P side actually. Means when we take that the diode is on, we are assuming that the diode is on, the current is flowing in the opposite direction from N to P. This is not possible for a forward bias diode. Current can never flow in N to P direction through the diode for a forward bias diode. It can never happen like that. So our assumption that the diode is on in the second method, it's false. It is not true because when we found out the current, the direction of the current is in the opposite direction. Okay, from N to P. Current can never flow from N to P through the diode. So it is not forward biased. Our assumption is wrong. It is reverse biased. The diode is off. Open circuited, reverse biased. Okay, so this is the second method. Okay, replace the diode with its equivalent circuit, assuming that it is on. Find the current flowing through the diode, the direction. The direction should always be from P to N. Okay, N to P, it is wrong. Okay, here it is flowing from N to P, the actual current. So that's why this diode here is off. So both the methods, they give us the same result, that the diode is off. As the diode is off, current is 0 ampere, voltage drop across the 500 ohm resistor is 0 volt. Okay, so this is the third question that we have discussed. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.